In these short videos, we're going to be working with the minus sign. Specifically, we're going to take a look at how we use the minus sign in factoring trinomials. Factoring trinomials that look like the examples shown here can be a little bit scary. Here are some things that we can use to help us factor them into two binomials. When everything is positive, the process is easy. You use plus signs. So we're not going to talk about this one. We're going to look at trinomials where we see one or two minus signs. Here are some things to think about that will help you to know what to do. Let's just think about this without using any numbers. We're just going to use variables to represent numbers in this initial explanation. You will need to find two numbers whose product is C and whose sum is B. If C is positive, the numbers have the same sign, either both positive or both negative. If C is negative, the numbers have different signs. One is positive and one is negative. Which number gets the minus sign? Sounds pretty easy, doesn't it? But where does that minus sign go? That's what's hard. That's what we're going to look at next. When you have a trinomial that looks like this, where the minus sign is between the second and the third terms, there's some things that we can do to make this an easier factorization. If C is negative, the numbers have different signs. When you have to factor a trinomial that looks like this, you know the first terms in each binomial will be x. We're using FOIL to think about this. So here are our two sets of parentheses for each binomial. Using FOIL to check, the first term times the first term. X times x will give us x squared. This part is correct, so x will go here and here. This is pretty much true of all of the binomials that we're going to be factoring today. When the minus sign appears here, this is what we know about the factors for that number. One of the factors is positive and one of the factors is negative. When a plus sign appears here, we need to think about those numbers in the factored binomials. Which one is going to be negative and which one is going to be positive. The larger number will appear with a plus sign, and the smaller number will appear with a minus sign. That makes B a positive number. We're going to find the two numbers that will give us the second and third term in the trinomial. In the FOIL process, we do this by multiplying the last numbers in each binomial to give us the third number. This number and this number are added to give us the middle coefficient. Notice we use signs in both steps. When we create the table of factors for this problem, we need to show the minus sign when we write the factor pairs. Here's what that looks like when we set up the table. We want to get a negative c or minus c result, so we're going to multiply our two factors to get the negative c and add them to get b, or the coefficient of the middle term. So a negative number times a negative number will give us a negative result. And we can also check to see if this combination of numbers will give us the coefficient of the middle term. We just need to add them. Make sure you use the minus sign when you do this. You need to get a positive b. This gives you the same number that you get if you did the outside and the inside multiplication in the FOIL process and then added the results. If you get that number, then you've factored it correctly. Let's see what it looks like in a problem. Our trinomial is x squared plus 5x minus 24. The minus sign appears here, so this is what we know about the factors for that number. The first terms in each binomial will be x. Because we have a negative 24, that means one of the factors is positive and one of the factors is negative. Here's what happens when the coefficient of the middle term is positive. It means the outside and the inside multiplications using the FOIL process would create a negative and a positive number. When we add them, the result needs to be positive. So let's get our binomials set up. The middle term has a positive coefficient. The smaller number will be with the minus sign, and the larger number will be with the plus sign in our factored pairs. So make a list of factor pairs and keep making them until you find a pair that you can multiply together and get a negative 24. There are many. we have a negative 1 times a positive 24. Multiplying them together, we get a negative 24, and that's consistent with what our trinomial looks like. Add those same two numbers. If you don't get 5, then you need to use another pair of factors. So a negative 1 plus 24 is a positive 23, and we need 5, the coefficient of the middle term. This won't work, so we're going to go to our next factored pairs. We have a negative 2 and a positive 12. A negative 2 times 12 is a negative 24. That's consistent with what we need. A negative 2 plus 12 is 10. And again, we need 5. This one won't work either. Our next factor pairs are negative 3 and 8. A negative 3 times 8 gives us a negative 24. A negative 3 plus 8 will give us a positive 5. Now we have the two numbers that we need. So now I can put into plus 8 here, and I could put a minus 3 here, or they could flip. It wouldn't make any difference if we had a negative 3 in the first binomial and a plus 8 in the second binomial. The results will be the same. Let's check our factorization. This is our original trinomial. Let's check to see if the factorization is right. We'll use the FOIL process. Multiplying the first two terms in each binomial, x times x is x squared. That's consistent with what we see in our trinomial. X times a negative 3, we're multiplying the outside two terms. So we have a negative 3x. We write our number first. Multiplying the inside two terms in each binomial, 8 times x will give us 8x, and we write plus 8x. Multiplying the last two terms in each binomial, 8 times a negative 3 is a negative 24. These terms are alike. Combine them. A negative 3 plus an 8x is going to give us a positive 5x. So now writing our trinomial over again, we have x squared plus 5x minus 24. This matches the original polynomial, and our factorization is correct. So now what happens when we have a trinomial that looks like this? We have the minus sign between the first and the second term, and our last term is positive, or we have a plus sign there. So we have x squared minus bx plus c. We're just going to use variables first to explain this process. If c is positive and b is negative, the numbers in the binomials have the same sign. They could both be negative or both positive. Because b is negative, both numbers will be negative. Here's the reason why. When you have to factor a trinomial that looks like this, you know that the first terms will be x. Using FOIL to check it again, x times x is x squared, so this is correct. When the minus sign appears here and you have a plus sign here, this is what we know about the factors for that number. Both factors are negative. When you multiply them, you get a positive number, or a plus c. That gives you the last term in the trinomial. Here's what we know about the middle term. Multiplying the outside and the inside two numbers and adding them gives you a negative term. A negative plus a negative gives you a negative result. It gives you the coefficient of the middle term, or a negative b or minus b. Both numbers in each binomial are going to be negative. We're going to find the two numbers to multiply that will give us the third term in the trinomial. In the FOIL process, this is multiplying the last numbers in each binomial. This number and this number are multiplied. Notice we use the signs in the multiplication. When we create the table of factors for this problem, we need to show the minus sign when we write the factor pairs. Here's what that looks like when you set up a table. Remember, we're multiplying to get a positive c, and we're adding two numbers to get a negative b or a minus b. So that means we're going to use two negative numbers. A negative times a negative gives you a positive, and that's what we're anticipating for our final third term in the trinomial. We can also check to see if this combination of numbers will give us the coefficient of the middle term. We're adding two negative numbers, and so the result should be a negative b or a minus b. We just need to add them. Make sure you use the minus signs when you do this. This gives you the same number that you would get if you did the outside and the inside multiplication in the FOIL process and added them. If you get that number, then you factored it correctly. Let's see what it looks like now in a problem. I have x squared minus 9x plus 18. The plus sign appears here and the middle term is negative. So this is what we know about the numbers in each binomial. Both of the factors are negative. So we can have our two binomials. We know we have x here and x here. Here's what happens when the coefficient of the middle term is negative. It means the outside and the inside multiplications using the FOIL process would need to be two numbers that are negative. When we add them, the result is negative 2. When we multiply the last two numbers, we get a positive number for our last term in the trinomial. Both numbers will have to be negative. Make a list of factor pairs and keep making them until you find a pair you can multiply together and get a positive 18. Add those same two numbers, and when you get negative 9, then you have the correct two factors. Our first two factor pairs are negative 1 and negative 18. Multiplying them together, we get a positive 18. Adding them, we get a negative 19. So these two factor pairs will not work. Next, we'll try a negative 2 and a negative 9. Multiplying them together, we get a positive 18. Adding them together, we get a negative 11. And again, we're looking for a negative 9. So we're going to try negative 3 and negative 6. So negative 3 times a negative 6 gives us a positive 18. Adding a negative 3 and a negative 6, we do get a negative 9. So now we know that negative 3 and negative 6 are the two numbers that will go ahead and join our two binomials. This is our original trinomial, x squared minus 9x plus 18. Let's check to see if the factorization is right. We're going to use the FOIL process. Multiply the first two terms in each binomial. X times x is x squared. Multiply the outside two terms in each binomial. X times negative 6 gives us minus 6x. We write minus 6x. The inside two terms, multiplying them, we get a negative 3 times x gives us minus 3x. Multiplying the last two terms, a negative 3 times a negative 6 gives us a positive 18, and we write plus 18. These terms are alike. Combine them. A negative 6x plus a negative 3x is a negative 9x. And now our final trinomial looks like this. X squared minus 9x plus 18. This matches the original polynomial, and our factorization is correct. What happens when you have two minus signs? When you have to factor a trinomial that looks like this, you know first terms in each binomial will be x. Using the FOIL process to set this up, first term times first term, x times x is x squared. This part is correct. And so again, each of these two binomials will have x in it. When the minus sign appears here and here, this is what we know about the factors for that number. One of the factors is negative and one of the factors is positive. When you multiply the last term by the last term, you need a negative result. So one number is negative, the other is positive. That gives you the negative result. In the factorization, the larger number will be negative, and that's because we have a middle term with a negative coefficient. Let's look at why we know this. The smaller number will appear with the plus sign. The larger number will appear with the minus sign. That's because when we add them, the result is a negative middle term. That's what we're looking for. So that will be the smaller, this will be the larger. We're going to find two numbers that will give us the third term in the polynomial. In the FOIL process, we multiply last numbers in each binomial. This number and this number are multiplied. Notice we use the signs in the multiplication. When we create the table of factors for this problem, we need to show the minus signs when we write the factor pairs. Here's what it looks like when we set up a table. We know we need to multiply two numbers to get a negative c, and we need to add them to get a negative b. Again, we know one is going to be negative, one is going to be positive. Using just the variable letters doesn't really tell us which one is larger and which one is smaller. We'll get to that when we look at a problem. But just remember this, multiplying a negative times a positive will give you a negative, and that gives us our third term. We can also check to see if this combination of numbers will give us a coefficient of the middle term. And this is where we have to recognize which number goes with the minus sign, which goes with the plus sign. Because adding a negative to a positive, we want to get a negative result. So we want to make sure the minus sign is correct when we do this. This gives you the same number you would get if you did the outside and the inside multiplication in the FOIL process and added them. When you add those two terms, you need to get a negative term. If you get that number, then you factored it correctly. Remember, you need a negative number for your middle term. Let's see what it looks like now in a problem. I have x squared minus 4x minus 21. The minus sign appears here and here, so this is what we know about the factors for that number. One of the factors will be negative, one of the factors will be positive. Again, in our two binomials, we can put x as the first term. Here's what happens when the coefficient of the middle term is negative. It means the outside and the inside multiplications using the FOIL process would give us two numbers, and when we add them, the result needs to be negative. This tells us that the smaller number is with the plus sign and the larger number is with the minus sign. So now let's go ahead and create our table. Remember, we're looking for a negative 21 for a result when we multiply our two numbers, and when we add them, we want to get a negative 4. Make a list of factor pairs and keep making them until you find a pair that you can multiply together and get negative 21. Add those same two numbers, and when you get negative 4, then you have the correct two factors. We'll start with 1 and negative 21. 1 times a negative 21 is a negative 21. Adding 1 plus a negative 21 gives you a negative 20, and we're looking for a negative 4. Our next two factor pairs are 3 and a negative 7. 3 times a negative 7 is a negative 21. 3 plus a negative 7 gives you a negative 4, and now we've found the factor pairs. So we'll put a plus 3 here and a negative 7 here. This is our original polynomial. Let's check to see if the factorization is right. Use the FOIL process. X times x is going to give us x squared. Multiplying the outside two terms, x times a negative 7 is negative 7x. Multiplying the inside two terms, 3 times x is going to give us 3x. Multiplying the last two terms, 3 times a negative 7 is a negative 21. These terms are alike. Combine them. Notice we use the signs here. 3 plus a negative 7x is going to give us a negative 4x. And now our final polynomial is x squared minus 4x minus 21. This matches the original trinomial, and our factorization is correct.